All right, next problem, we have a random sample of 21 observations taken from a population that is normally distributed, produced a sample mean of 62.5 and a standard deviation of 5.5. So I want you to look at that first before you move forward and say, okay, this is giving me a sample mean and a sample standard deviation. So within these 21 observations, I am producing a sample, and I'm producing a sample mean and a sample standard deviation. So we're looking at that. So when I get a sample standard deviation, I am using t. Okay, so that's the first thing. I need to use t because I'm given a sample standard deviation. Now let's do the rest of the problem. Find the range for the p-value and the critical and observed values of t. So it tells you to use t here when you get further down. You do need to be able to distinguish it. For the following test of hypothesis, using a significance of 0.01, okay, you have a null hypothesis that the mean is equal to 62.5 versus an alternative hypothesis that the mean is greater than 62.5. Okay, so when I'm doing this problem, first of all, my alternative hypothesis has the mean is greater than, so it is pointing to the right, so this is a right-tailed test. Okay, so that's the first thing. Now, we need to find that a critical value of t in the right tail. Okay, so we need the value of t that produces a 0.01 in the tail, meaning that I've got 1% of this curve. So 1% of this curve is probably over here between 2 and 3, maybe even further over here. But let's actually get that value. So my significance level is 0.01. I need my degrees of freedom in order to do that. So remember, my degrees of freedom is going to be the sample size minus 1. So if it's a sample of 21 observations, my degrees of freedom is going to be 21 minus 1, so 20. Okay, I use a t-value calculator. Okay, just type that into Google, t-value calculator, and let's go ahead and do that. So we have a significance level of 0.01 and a degrees of freedom of 20. And that gives us 2.528. Okay, so that's your t-value. So what was it again? 528? Yeah, 2.528. So we're going to go here, 2.5, roughly like right here, 2.528. Okay, what does that mean? Well, that means that this is my critical value, and in the right side of the tail, so on this side of the tail, okay, if I do my test statistic and it comes over here, then that is going to mean that I will reject my null hypothesis. So this is your rejection region. This is your non-rejection region. All right, so let's find out whether we want to reject that or not. Let's get the information we need. So we have a sample size of 21. We have, let's see, sample mean of 62.5. We have a standard deviation of 5.5 inside that sample. And we already have our mean, our null, and then our alternative here. Okay, so what we want to do is we want to find the z value. So our test statistic here. So we've got z is going to be x bar minus the mean over the standard deviation of x bar. Then the standard deviation of x bar is going to be, the standard deviation over the square root of the sample size. Okay, so if I go ahead and do that, I'm going to get 5.5 over the square root of 21. And let's see what that gives us. So 5.5 over the square root of 21 gives us 1.200, and I can round that up to 2. So 1.2002. Okay, so let's plug those in. So my x bar is 62.5. My mean is 62.5. Well, I didn't really even need to find the standard deviation in that case. But this is over 1.2002. My z here is 0. 62.5 minus 62.5, 0. So this is my z, 0, this is in my non-rejection region. So when it's in the non-rejection region, okay, this is okay. That means we can accept the null hypothesis. But we don't say accept the null, we say this. We say fail to reject. So we're going to fail to reject our null hypothesis. Okay, so that's our conclusion here. And then what we would say here, if we were putting in our values here, this is our critical value t, we say t is 0, so it is greater, well, okay, 0 is greater than 2.528. Okay, and then it also is asking for the p-value range. Okay, so your p-value, if your significance level is 0.01, that's your alpha, you need to find the p here. So the p here, this should just be 50% for this one because it's 0. But if we went through and technically did this, for a t, to find the p-value, the p of t, okay, you're going to use TCDF in your calculator. Okay, so you do TCDF, lower, then upper, and then your degrees of freedom. Okay, so in this one, we would go our lower limit. It actually isn't going to matter with 0, so we'll just do 0 as our lower limit. So second bars, TCDF should be number 5 there. 0, then our upper limit, we're going to make 99, and then the degrees of freedom is, we found was 20 before. So we get 0.5. Okay, so the P of T is 0.5. We compare that to the significance level, which is 0.01. We say 0.5 is greater than 0.01 when P is greater than alpha. We fail to reject.